Hi everyone, welcome to Cloud on Air. My name is Jay Jenkins. I'm a customer engineer based in Singapore. In this session, we're going to talk about serverless and what it means for you and your organization and how you can start to use that. As you can see from where I am, I'm going to be doing this session for you today, and I'm excited to be a part of it. So let's get started. So serverless computing, what does that mean? So when I think about serverless computing, I like to sort of start thinking, I guess, about Google.com. Right? If I think about Google.com and how I use that today, I can go into search or in my Chrome quick search and search for anything. And what I don't think about is what's happening in the background. Somewhere, a tiny process spins up just for me, searches across trillions of web pages, and then delivers a set of results. I don't think about the servers that are running. I don't think about what's happening in the background. I just care that it gives me those results in milliseconds. I think about when I go into a hotel and I connect to the Wi-Fi. The very first thing that I do is I go to Google.com. And if Google.com doesn't show up, my first thought isn't that Google is down. My first thought is that I'm not connected to the internet. So let's think about then what serverless means. And serverless is a bit of a buzzword at the moment, right? If you take a look at Google Trends and the interest over time in serverless, it's gone up drastically. You can see the little spike at the end. I like to think that it's because we're having this session today. Probably not, but it's a nice thought. So let's dive into this a bit more. What is serverless? So let's think about compute and how we how we manage our applications today. If we had true serverless architectures, it would be like electricity. If I'm designing an appliance, I don't have to contact the power company and tell it how much energy I need and what sort of generators that they'll need to choose in order to help me run that appliance. I can just plug that into a wall and it'll run my appliance. Why should it be any different for applications? And in fact, that's our goal. That's how we want to run applications in the future. If we take a look at the choices that we have on Google Cloud Platform, we have infrastructure on the left all the way to cloud functions on the right. And let me go through those briefly. Compute engine, infrastructure as a service. You choose your server, you choose your operating systems, you choose your CPUs, you choose your GPUs, you choose your RAM. Everything above that, you're managing and you have to take care of. And that's a lot of operations. If you move slightly to the right, you have things like container engine. The container engine allows you to create a heterogeneous environment across those compute engines. But today, you still have to choose what type of instances you're going to run those on. If I then move over to App Engine, and I'll actually start with App Engine Flex. App Engine Flex allows you to take that container and hand that over to Google. And we'll actually scale that for you. We'll load balance that for you automatically without you thinking about it and without you thinking about the underlying OS that's supporting that. And then we have App Engine itself, which provides you a way to actually scale those applications down to 0. And then finally, on the right, and we'll go into this in a little bit more detail in a bit, we have Cloud Functions, which is essentially a function as a service. So you put your code in, we'll run that, and it's priced based on how much you actually call that function. But what about other things? So people do like to think about serverless as compute and think about running their code. But what about storage and databases? Again, we want to be able to support you where you're at. So you could use Compute Engine and install your own databases. But we give you other options as well in terms of managed services and managed databases. So again, from the left, we have things like Cloud SQL, which supports MySQL and Postgres. We have cloud storage, which is essentially storage as a service. Again, you don't have to really think about how we manage that storage for you. You're just putting your objects there and paying just for how much you're using. Cloud data store, which we price based on reads and writes and other functions. Again, you don't have to think about the underlying servers that are actually supporting that. Cloud Bigtable, Cloud Spanner, our large high throughput databases. Again, we want to be able to give you that scalability without you thinking about that underlying infrastructure. And finally, BigQuery, which allows you to run ad hoc queries on petabytes of data. And again, our goal here is to give you this sort of flexibility and give you this agility with your applications, while enabling you to think less about ops and focus more on your apps. And another side of that are things like data pipelines. So we had some great presentations this week around things like Dataproc and Dataflow and PubSub. And again, with these sorts of pipelines, we don't want you to think about, or want you to have to think about, the underlying infrastructure that supports those. We want to be able to scale those automatically for you. So here's an example architecture which we believe utilizes a lot of these serverless functions automatically for you. So using something like application engine for your web front ends, which might publish things to Google Cloud Storage or end up in message queues using PubSub. Maybe using Cloud Functions for your backend processing, which can then call machine learning APIs or databases. And we actually have serverless capabilities, or moving you towards serverless, in all of these areas. And I think I really want to get that across to you today, that serverless isn't something that we can sell you. Serverless itself is a goal. It's a goal for application development, which moves you from DevOps and pushes you towards low ops or no ops. So let's look at an example application. So let's say that you are building a content analyzer. So you have Compute Engine, you have your infrastructure as a service. You're going to deploy your software there in order to manage the content that's being published to that from a mobile device. And maybe you're taking that content and doing some text analysis or some image services on that. But of course, you're going to grow. So now you actually have to balance that across multiple compute engines, each of those doing their own text analysis and image analysis. And you have to balance across, do load balancing across all of those compute engine instances. So now you've added an extra layer of operations, because you have to think about that scalability, and you have to think about how your application is going to serve more customers. Let's go beyond that. You're extremely successful. So you have your load balancing, and maybe you're putting a compute engine instance in front of that in order to catch all of these inbound messages, put it on a message queue, and then publishing that to your various compute engine instances. So this will help with throttling and controlling some of the load on those back-end instances. But you still have to now worry about all of that, and you have to worry about how your platform is going to manage that. So if you have a big launch approaching, there are a lot of things that you have to think about, not only from a development perspective, but also from an operations perspective. You have to do a lot of planning. You also have to plan for upgrades, what happens when the underlying operating system needs to be upgraded. You have to design that scalability in mind. So there's too much fix and fiddle, right? You're wasting your effort. You're wasting the time of your developers by focusing them on things like scalability, capacity planning, whenever they could be focusing on your application, on the new code that you're developing. So this is a great post by Kelsey Hightower that he had last month. He talks about ops lock-in. And essentially, another thing that happens is if you're implementing all of the scalability yourself, and you're implementing all of this using something like infrastructure as a service, you're actually locked in. You actually cannot innovate faster than what your ops team can actually support. By taking that away, by moving more towards serverless operations, and by focusing more on your applications, you're going to be able to innovate faster. Right, so let's revisit our content analyzer and think about, rather than going to this, maybe we could look at something else, which is just focusing on your code. Right? And that's really the goal of serverless. So first I'll talk about platform as a service. which is a good step in moving towards serverless applications, because essentially with that, Google will take care of the scaling, will take care of the load balancing across multiple instances so that you can serve your app, whether it's 1 million users or 0 users, because we can actually take that and scale it down to 0, so that when nobody's using it, you're not paying anything. Right, so what is Platform as a Service? So Platform as a Service is a fully managed implementation where you can focus on your code, you can build and test locally, and then deploy that into App Engine. You do have your choice of runtimes, so Java, Python, Go, PHP, and we also support custom runtimes as well using App Engine Flex. So if it can run in a container, you can run that on App Engine Flex. Right, so how does that then compare to something like serverless? If I think about Platform as a Service, there's no real need for me to manage servers, although there are individual instances, and I do think about things at an instance level with Platform as a Service. I don't really have to think about the underlying server at all. It will automatically scale for me as needed, and there's no upfront provisioning. And it's also stateless and ephemeral, which actually helps with that horizontal scalability. So if I think about the entire computing continuum, where I have things like Compute Engine on the left, where certainly you can support your traditional DevOps structures, to Container Engine, to App Engine, and then to Cloud Functions, serverless kind of sits in here from an ideal standpoint, right? And the idea is we can certainly help you with everything on the left, but we also have everything that's required to move you towards the right, to get rid of the heavy ops that you're doing today and move you more towards, as I said before, a low ops or no ops implementation. Right, so it has many attributes of what we would think about as serverless. So let's think about serverless today. So again, people think about only compute, running code, but maybe it's also about non-compute, other types of functions like databases, and even machine learning, which I can talk about later. It's event-based. So again, what we don't want is something that's sitting there waiting for somebody. We want an event to happen before the application runs. And you pay only for what you use. And I think you'll see this in a lot of our payment models, even on infrastructure as a service, that we're trying to take away the headaches of all that capacity planning to make sure that you only pay for what you use. So let's think about, I guess, serverless on Google Cloud Platform and the things that we have to support and the things that we've been building over time. So it started back with App Engine, and then we moved to things like BigQuery, which is a database that you don't have to worry about indexing, you don't have to think about optimization, and it can scale to petabytes of data. You have things like cloud storage, which is our object storage, data store, a NoSQL database, data flow, which is around ETL tools, and if I had the time, I'd also demo that for you today. Firebase, which I am going to demo for you today. PubSub, which is our messaging queue, where you're paying only for the amount of data that you're pushing through that queue. So again, if you're not using it at all, you're not paying for anything. If you want to publish one message, you only pay for that message. Or if you want to push millions of messages per second into PubSub, then we can support that as well. I'll be talking about Cloud Functions, which is currently in beta. We also have the Cloud Machine Learning Engine. So if you're doing machine learning today using things like TensorFlow, you might be, again, worried about scalability and how you're going to do that distributed training. Machine Learning Engine can help. And then, as Wenwu presented this morning, we have Cloud Spanner. If you'd like to know more about Cloud Spanner, we'll be having another session later today. So please join that. So let's talk about functions as a service. And people normally think about functions as a service as serverless. But as I said, I think of serverless as a goal for application development. There's no end point today in terms of a sort of flag you can plant in the ground and say we're serverless. So Cloud Functions is a serverless environment to build and connect cloud services with code. So what does that mean? So again, you don't have to think about the servers. It's not that there are no servers, right? Because obviously we're Google, we have data centers, and there are servers running, but we want to make sure that you don't have to think about it. We will automatically scale that. So again, if you're running the function once or you're running it 1,000,000 times, we should be able to scale that based on how much you're using it. And we also want to make sure that you only pay for what you use, which means that we only bill you on a per 100 millisecond basis, right? So on the compute side, on the infrastructure, it's per minute. On the Cloud Functions, it's per 100 milliseconds of use. So what types of Cloud Functions do we have? So we have background functions and event-driven functions that you can access today out of Cloud Storage and Cloud PubSub. And we also have HTTP functions, which are useful for things like APIs, webhooks, or even calling them directly from a browser. And if we think about how HTTP functions can be used, there are things like Google Assistant and other Google products, but also other things. So the Internet of Things. And later today, KJ Pittle is actually going to be talking about machine learning and bots. HTTP functions or Cloud Functions is a great way to actually expose and interface to those bots. So what are some use cases? So there are things like webhooks. So again, things like bots use webhooks. You can also do implementations into Slack as well. So we actually have some code available for you to look at if you're interested in doing that. You can establish API endpoints with Cloud Functions. You could do lightweight ETL. So maybe you don't want to implement Dataflow or some other ETL type tool. Cloud Functions can actually make an external call to a database, for example, and pull in reference data before it goes into your database. Internet of Things, which I mentioned, and cloud events. So again, another great example is I'm using something like Google Cloud Storage. I'm uploading an image, and maybe I want to automatically generate a thumbnail for that image. So you can do that using Cloud Functions automatically. And PubSub, so I'm getting messages through a queue. I want to perform some discrete action. I can do that with Cloud Functions. So let me do a quick demo. So here I am in the console. Let me maximize this to make it easier to see. You can see I have a few functions, and if you're observant, you'll see that there are some Firebase functions in there, and I'll talk about those in a bit. But first, let me show you how easy it is to actually create a function. So I'm just going to click on Create. I'll just leave the default name. I'm going to run an HTTP trigger because that's going to be the easiest thing to demo. You can see that it's giving me a URL. And I'll just use the inline editor. So let's get rid of those comments. Let's get rid of all this error checking. We don't need any of that, do we? And I'll just assume that everything is OK. I'm just going to say hello. And in order to make it easy to test, I'm going to access a query string. And if I don't have that query string, I'm just going to have it say Cloud OnAir. So let's close that brace, make sure that my code is going to run. Great. I'm going to choose a staging bucket. So we'll put that inside of Awesome Demos. And I'm going to create that. So let's think about what that's doing in the background. So from that simple function, which is a Node.js implementation, it is actually creating that endpoint. It is actually going to create load balancing on top of that function. And it's going to deploy that actually to a tiny container that's sitting inside of Google, which we are going to automatically scale for you based on the need. So let me quickly go back to the slides. So you saw that I used the console UI. You can also use the command line in order to deploy those as well. Let's go back. So you can see that it is now deployed. I'm just going to run that. You can see it says hello Cloud OnAir. So great, my code worked. And if I pass it a URL, right, hello mom. So there you go. So very easy, very quick and easy to do in order to deploy a cloud function. So there you go. With 3 lines of code, it created an HTTP endpoint, a fully qualified domain, dynamically generated SSL. So again, let me show you that. Right, so completely secure connection. Auto scales that, and you don't have to worry about the underlying infrastructure. So again, it's a really good example of what serverless means or what you can do with serverless. And error reporting is included. So we do have logging. You can publish those errors into Stackdriver as well. And you can use sort of a basic console.log in order to publish those errors. So you're going to have to make some choices, right? So if I sort of take a look at X as a service decisions, do I use something like Cloud Functions, or do I use something like App Engine, Platform as a Service? So Cloud Functions scales at the function level. App Engine scales at the application level. And while a lot of that is our sort of HTTP requests when it comes to App Engine, it is really about scaling the application, not the function. While you could write an entire web page with Cloud Functions, it's sort of not its purpose. We really want it to be able to run discrete functions. Cloud Functions per 100 millisecond billing, App Engine per minute billing. With Cloud Functions are built to be event-triggered. They're built to be event-driven. Platform as a service, you could have events as well, but those events are basically manual, or you would manage those events yourself in other applications. Cloud Functions today only supports Node.js. App Engine supports multiple language. And Cloud Functions are basically around APIs. App Engine can do APIs, but it's basically built for the web. App Engine also allows you to do things like traffic splitting and versioning. So if you're doing things like green-blue rollouts, or you're doing things like traffic splitting to do A/B testing, App Engine is perfect for that. So let's move on to backend as a service. And backend as a service is taking your application and not having to worry about how those services are scaled that are supporting it. And I'm going to talk about Firebase, because I feel like Firebase is a really good example of how backend as a service works. So backend as a service, Firebase works on Android, it works on iOS, it works on the web. So if I take a look at the Firebase features, I certainly don't have time to go through all of these features today. But what I do want to understand is specific things that are really going to help you understand how this can help you with your application. Right? So in terms of the developer experience, right? Those backend services. So things like a real-time database, authentication, hosting, storage, cloud messaging, and remote configuration. But I also think it's important not to leave out sort of the things on the right, which are around sort of things like growing your application. Again, especially for those Android developers out there, who I know that have been a lot in the comments over the past few days. It is also about growing your application. So looking at things like acquisition and re-engagement, and also earning from your application as well. So we do have plugins available for AdMob. So Firebase has a real-time database. It's a cloud-hosted NoSQL database, and I'll actually give you a demonstration on how that works. But it does synchronization and conflict resolution in real time. And what do I mean by real time? Real time means that, for instance, I could even create a chat app using the real-time database. And I'm going to show you a chat app later. And it will automatically update across devices in real time. And that works even if you're offline. So if you're offline, we will actually store those transactions locally, and then as soon as we're reconnected, we will publish those back into the backend database so that, again, that can be replicated to all the devices that are attached. We also have cloud messaging. So again, if you're creating applications across different platforms, messaging can be a problem. How do I do messaging in iOS versus Android versus the web? And what we have are notifications that can help you drive user interaction, and that includes doing Chrome notifications as well. So again, if you're developing a web application, we can make sure that you can call the notification once, and that works across devices. And finally, authentication. So authentication is normally a lot of work for developers. And what Firebase allows you to do is, with a couple of checkboxes, add authentication to your application. And we support multiple types of accounts: Google, Facebook, Twitter, and even GitHub for your sign-in. So backend as a service architectures allows Firebase to take that information to your app, automatically provision and update that database, including its underlying schema, in real time. And that works across multiple devices, and in fact can synchronize that across multiple devices as well. So with that, you might want to take a look at database decision. So when do I use Firebase as a database, and when do I use something like Cloud Data Store? So Firebase as a database is a NoSQL database, as is Data Store. Firebase database is really efficient for mobile applications, although it can be used for the web, whereas Data Store works extremely well for more high-throughput back-end services. The Firebase database is really only accessible via a web app. Cloud Data Store has massive scalability. Firebase database does have fantastic things like real-time data sync into your application. Cloud Data Store requires querying of that database in order to update your application. So actually, before I do this slide, because I have a little bit of time, I'm going to do a quick demo for you around Firebase. So I've created this nice little chat app, and you can see here I've got sign in with Google. So what's that look like on the back end? So here I can choose a sign-in method for my application. You can see right now that I have Google enabled, but it has support for other access points as well as just a basic email password. You can see that right now I don't have any users. On the database side, while you can see that I've provisioned a database, there's nothing in it at the moment. So it's not even a schema. And with storage, you can see that I have a bucket, and you'll notice that this is actually using Google Cloud Storage on the back end, but again, there is nothing in it. And then for the functions, I've actually published some functions for the application as well. So you can see the little function that I just created, but also in this you can see add welcome message, blurring offensive messages, and sending notifications. So the welcome message looks for an authentication event. So as soon as a new user authenticates into the application, I can detect that and send them a welcome message. Blurring offensive images does something pretty cool. The cloud function actually integrates with the Cloud Vision API to examine the image and see whether there's adult content or violent content in the image, and then we'll actually blur that image for the users. And the last one is around sending those notifications. So because this is a chat app, if I don't have focus on that tab, I might want to send a notification to the user that someone has sent them a new message. All of these things are event-driven services that call cloud functions. So going back to the chat app, I'm going to sign in with Google. Here you see that I'm signed in, and you can see the welcome message, right? So that was based on a cloud function event that actually now sent me that welcome message. You can see that I type a message here. I can type a message here. And if I go back to the database, you can see a few things. Number one, that I actually have a token from that user. Number two, I have messages, one which was written by the Firebase bot, and one that was written by me. So what happens if I change this? Right, you can see that it's updated my tree. If I go back here, it's updated immediately in the application. And this is what we mean by a real-time database. Now, I also allow people to upload images. So let's upload an image of a dog. And where is that getting stored? So again, if I go back to my application, I can go into storage, and I can see that object is there. So of course, this is the internet. I should probably balance that out by uploading a cat. And the internet is full of cats. So I could use the Cloud Vision API to actually look at this image, decide what's in the image, and blur that out, as I did with offensive content. And in fact, my application is designed to do exactly that. So you can see that I've made a call out to the Cloud Vision API, detected that a cat was in the image, and then blurred that image out. So again, Cloud Functions allow you to do these fantastic things with your applications that can be defined within a specific discrete function. So let's go back to the presentation. So should you go serverless? So if you have existing monolithic applications, it's going to be difficult. But that's why Google Cloud Platform is designed to meet you where you are. If you have these monolithic applications, we can support you on infrastructure as a service and give you the capability to move down that serverless path. If you have extremely long-running compute tasks, you're going to have to choose the types of services that are available that can serve that. So Cloud Functions, for example, is not designed to run long-running compute tasks, but maybe that Cloud Function calls a message queue, which then calls Application Engine in order to run that long-running task, or perhaps it calls an API endpoint inside of Compute Engine that runs that long-running task. Do your applications need guaranteed response times? Because remember that we are auto-scaling these Cloud Functions, and these are meant to be functions. If you're looking at doing something like a transactional payment database, again, maybe something like a Cloud Function isn't good for that. However, if you want to send them a welcome message based on that Cloud Function, Cloud Functions are perfect for that. And in general, for serverless, you really want things to be stateless and ephemeral. So you want to make sure that those applications at the code level do not contain the state. You want to make sure that you push that state down into your database or some other place where consistency can be maintained. So we do have other managed services as well, some which I haven't had time to go through in depth. But it's important to take a look at the platform and make sure that you're targeting low ops and no ops types of applications for your services. By doing so, you can make your applications flexible, more flexible overall, and you can make sure that you keep your teams agile, and you make sure that your teams are focusing on the right things, which are functions and features for your users, not on disk storage, not on how many processors they need, and not how much RAM they need. So to sum this up, this is a really good slide taking a look at the different types of compute tasks and data tasks and where you might be able to use serverless options with those. So what do we learn? I think we learned what serverless is, or what a concept of serverless is, and how you need to move your applications towards serverless. It's not necessarily one or the other. We talked about what serverless means on Google Cloud. We talked about comparing the different types of services, so platforms, functions as a service, backends as a service. And we talked about how our managed services that we offer. Please provide us feedback, and we can go into depth in a future session. Right, so think about that. Think about what you want to use, and thank you very much. And we'll move on to Q&A.
Great. Thank you very much, Jay. That was a super useful session. I know myself, having written code maybe in a past life, I would love this to have been around then. Makes it super easy. Write something, literally click a button, and off it goes. So I've been busy answering questions. We had a lot of good questions come through. Someone said they didn't quite understand the difference between platform as a service and serverless. Wonder if you can just go through that one more time for them.
Sure. So I think about serverless as a continuum, right? So platform as a service, as an example, with App Engine, you still have to worry about the platform. You still have to think about the number of instances that you're using that. And while that gets you down the path towards serverless, ideally with serverless, you're not thinking about things at an instance level. You're thinking about things at a more finer grained level. So for instance, if I've just got a couple of users, there's sort of this large jump between 0 instances and 1 instance in terms of application engine. And again, a jump between 1 and 2. If you're running large-scale apps, it does take on many of the features of serverless because you're only sort of worried about things in a much smoother level.
Sure.
But for smaller applications, those jumps are quite large when I think about sort of what the ideal is for serverless.
Yeah, almost seems like a waste. If you can keep things small, you should keep things small, I think.
Absolutely.
Yep.
Yeah, keep things small, keep things discrete. Microservices are talked about a lot today.
Another buzzword.
Another buzzword, but I think it's important when you're architecting your application to think about things like microservices. And if you're using microservices today, maybe some of those services could be moved to something like Cloud Functions.
Yeah, great point. So we've pulled together a few questions that have come through, so it'd be good to quickly run through those now. So the first one is, what's the best way to write data to a database with Cloud Functions?
Right, so assuming you're not using something like Firebase, which has a really nice real-time database built in, we have a lot of other database options, right? And your Cloud Function might want to write to those databases. So the application, or Cloud Functions use Node.js today. And Node.js does support NPM, which are prepackaged modules, which support a lot of our underlying databases. So you can actually use those same modules, those same packages, in order to write to our underlying databases as well.
Yeah, I've started getting my hands dirty a bit with Node.js. I've been very surprised at how many modules there are available. Literally install, done, and off you go.
Yeah, Node.js is extremely popular, in particular with web developers that already have a lot of experience and knowledge around JavaScript.
Yep.
So Node.js is an easy progression for them.
Yep, great, thank you. OK, so second question is, how should I secure my Cloud Functions from other people running them?
Yeah, absolutely. So you saw that I created an HTTP endpoint, but there are other endpoints that you can create as well. One of them, for example, is using something like PubSub.
Yep.
Right. So PubSub itself is a publishing. It can publish messages specifically to Cloud Functions and manage a lot of that traffic. It can also help you throttle a lot of that traffic into Cloud Functions as well.
Yep.
So in that sense, the authentication is then pushed out to the
PubSub
calling application, right, that'll actually be using that Cloud Function. Firebase also provides authentication as well, so if you're using those events, and obviously if you're using something like Cloud Storage events, that would be protected by the other application as well.
Permissions on the bucket, etc.
Right. Now, if you wanted to call the Cloud Function directly, or you wanted to make it so other people could call that Cloud Function directly via HTTP, again, looking at Node.js, you can do things like access your tokens, access your OAuth, as an example, in order to control, again, the access to those applications. or to those functions.
Yep, we actually had a question come through about, if I want to write a chatbot with Facebook using API.ai, can I use a webhook out to a Cloud Function? Absolutely. Also promote KJ's session later on today about API.ai. So yeah, I think we're covering that question well.
Definitely.
So next one is, I know Cloud Functions is in beta at the moment. Will there be support for other runtimes going forward, do you think?
Yeah, absolutely. Look, we started with Node.js because there were so many web developers, and actually this is something that the Firebase developers have been asking for a long time. So I think in terms of the first language, I think we've made a good choice. There are other languages that we need to support. Absolutely, absolutely true. And just like with our other platforms, we will slowly roll out additional languages as it matures. So it is in beta at the moment. Once it goes into production, we should have more languages available to you.
Cool. So if people are a developer like myself, my code is probably going to be a little bit buggy. I'm going to need to do lots of logging to figure out what's happening in my particular function. How would I get alerted to errors and logging? How do I go about finding what's happening in my function?
Absolutely. So you can use your basic console.log in order to put messages out to a log file, which are available to you. You can even publish those into Stackdriver. So if you have a large application and Cloud Functions is just one of those points you need to be able to manage, you can actually publish that to Stackdriver, manage the application as a whole, and have that logging available to you to help you debug your application.
Yeah, I was actually just reading a little bit more about that while you were talking. Also, through the command line, you can literally just bash out, gcloud function log, give me my errors. So as you're developing, pretty easy to get some feedback, especially if you're like myself, you might not know what you're doing with Cloud Functions off the bat.
I mean, I was using the console UI. I was very, very scared that I wasn't going to close the parens. So you might have saw me pause because I was just counting parens, right? So the console UI probably not the best place to deploy from. So we definitely want to make sure our logging is rich, and we give you other options there.
Yep. So good segue, deploying. If I want to run things locally, I don't want to necessarily be pushing code straight away to cloud. What options do I have for running things locally on my laptop before I push?
Yeah, so we do have an SDK available, which allows you to emulate these functions locally, so you can run these functions locally and test them before you deploy. When you're ready to deploy, you simply zip that up. It gets pushed to cloud storage, and it will then deploy it from cloud storage.
So effectively, I can be either running Node locally for myself, use this SDK, make sure I'm not doing things out of bounds, and push and off we go.
That's right. And then once it's up there, you have all the logging capabilities available.
Perfect, perfect. Well, Jay, thank you very much. It's been a very, very useful session for myself, and I'm sure for everyone watching.
Thank you, Richard.
With that, I'll hand it back over to you to close things off.
All right, so thank you so much for joining us. Thank you for your questions. I'll hop in a second if there are any left. I'm happy to answer a few more questions. What do you do now? So number one, get certified. So we do have training available. We do have certification programs available. Please visit our website. We have hands-on labs available as well from Quick Labs and Coursera. You can contact us if you have any further questions or you have a complex application that you want to know how you can move that to Google Cloud Platform. And we have a free tier available. So if you go to cloud.google.com/free, you can learn about those free tiers and use those applications. And we do have a G Suite learning as well. So I know this one wasn't focused on G Suite, but if you're interested in G Suite, please go to that training page as well. So thank you very much. We do have KJ's session coming up on machine learning. I will do this session again later this afternoon. So if you wanted to watch it again or wanted to forward the links to your friends and colleagues, please do. So I'll see you then. Thank you.